Okay, so today's notes, I actually have a printout for you. It's stapled, but you can undo the staples when you put it inside of your binder. I just had it stapled so that they would all stay together. And then you could get your packet and then take the staple out, and then that way you can flip through the pages easily in your binder. So topic is section 8.1. You'll have to copy down the essential question. How do you find the sum of the measures of the interior angles of a convex polygon? So you can pause so that you can get that written down and then start back up when you're ready. All right, so next, main idea polygons. So we have a couple vocabulary terms here. The first vocabulary term is polygon, and this is also known as shape. Polygon is better just because it has these specific things here. Sometimes when you hear shape, you think of a circle also, but a circle is not a polygon because it violates one of these. So a polygon is a closed figure with the following properties. It is formed by 3 or more segments, and we call those sides. And it can't be 2 segments because if you have 2 segments, it's not closed. Okay, so that's why it has to be 3 or more. And then again, segments, so no curves. And then each side intersects exactly 2 sides, one at each endpoint. That's important, and we'll see what that means more closely when we get to the first example. All right, next is a regular polygon. So our next term is regular polygon. And a regular polygon is a polygon with all congruent sides and all congruent angles. So an example that we've already seen before is an equilateral triangle, because remember that means all 3 sides are congruent and all 3 angles were congruent. So an equilateral triangle is what is a regular polygon. We would technically call it a regular triangle, but instead of calling it a regular triangle, it has a special name, equilateral triangle. Okay, so a polygon with all congruent sides and all of the angles are congruent to each other. Okay. All right, so example 1, a multiple choice. So which of the following is a polygon? Okay, so I want you to take a moment to answer it based on what you think. There is only one answer that is correct. So pause it for a minute here and you decide. All right, so part A, letter A, is not correct. This one violates the curve piece. Okay, so it has to be formed by 3 or more segments, and this one has a curve, so A is out. Okay, B is also out. This one has all segments, but it violates the second one. It says each side intersects exactly 2 sides, one at each of its endpoints, meaning if I were to look at this segment right here, this segment is attached or adjacent to this segment. So 1, 2, it's also adjacent to this one, 3, and 4. So again, this is not a polygon because it violates that second piece, because if any segment, well, not every segment, but if there's just one segment that you choose and it's touching more than just 2 other ones, then it is not a polygon. So B is out. So then that just leaves C. So we have all segments, no curves, and then if I were to take this segment, it's only attached to 2 other segments. If I take this segment, it's only attached to 2 other segments, and that happens all the way around. So example 1, the only correct answer here is C. And we talked about why A and B were violated by the definition. Okay. All right, next, I gave you pictures of what we call convex polygons and concave polygons. Okay. So what I want you to do is take a moment and look at that. I'm not going to give you an actual definition, I want you to come up with your own way to figure out the difference between a convex and a concave polygon. So on that left-hand side, that page that's blank on the left-hand side of your notebook, I want you to I want you to write how you will tell the difference between convex and concave polygons. So go ahead and pause this so you guys have enough time to write that out, and then we'll see what you put. Okay, so if we look at these, one thing that you may say is that the convex, all of these vertices are pointing outward. All of those are pointing outward, whereas concave, some of them are outward, but there's at least one that's pointing inward. So that's one way you could have written that you'll remember this. The actual definition says that if I take any of these and draw in what we call a diagonal, and we talked about diagonals of a square when we were doing 45, 45, 90 triangles. And what a diagonal is that if I take one vertex, it's already connected to that vertex, but it's not connected to that vertex. So I could connect them and I would make a diagonal. From this one, I could also make another diagonal there, and then there, that's already connected. So I've got two diagonals that come from that vertex. Okay, and I could do that all the way around. But what convex says is that if I draw in all of the diagonals that are possible to draw, and all of them are inside the polygon, then it's a convex polygon. Here, if I draw in all the diagonals, so I can draw from there to there, attach there and there, these are not attached. If I draw in all of the possible diagonals here, at least one of them falls outside of the polygon. So that is a concave polygon. So that's the actual definition, but if it makes more sense however you said, because what it'll come down to is I may ask you which of these polygons is convex or which is concave or something like that. And the formulas that we're going to talk about later only work when you have convex polygons. They do not work when you have concave polygons. Okay, so that'll be important. All right. Now let's talk some more vocabulary. So number of sides that a polygon has and what we call it. So the first one, hopefully we all know this one, number of sides. If there's 3 sides of a polygon, it's called a triangle. And we had different classifications of triangles, but just the overall thing is if it has 3 sides, it's called a triangle, which makes sense. You've got the tri part in front. 4-sided figure is a quadrilateral. So the quad in front is the 4, quadrilateral. Now you may be thinking, but isn't a square a 4-sided figure and a rectangle, etc.? Yes, but the class that we call just every single 4-sided figure is a quadrilateral. Then we have some special types of quadrilaterals that we can talk about. We're actually going to talk about those this chapter. 5-sided is a pentagon. And you can pause if I go too fast. 6 sides is a hexagon, and you will need to know these names. This will be part of what you're going to be tested over. And I'll show you how you'll be tested over that. 7 is a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. Then we skip to 12 because 11 does have a special name. It's called an undecagon, UN decagon. So decagon, the 10, and then the UN in front would be like adding one more to it, but we won't use that one as much as we will use these other ones. 12 is a dodecagon, so decagon is 10, the do in front is the extra 2, so dodecagon is 12. And then after that, we get less creative. So if we have n sides and it's bigger than 12, so like if I had a 13-sided figure, so if n equals 13, this would be called a 13gon, just 13 dash gon. Not super creative after that. If I had a 50-sided figure, then I would call it a 50gon. Okay, so you will need to know these And again, I'll show you. I'm not just going to come out and ask you what's a five-sided figure called, and you would just have to say pentagon, but it'll be embedded in a problem that if you don't know how many sides that has, then you may not be able to answer the question. Okay. All right, next you're going to do this activity. We'll do the first two rows together, and then you'll do the next three, and then you're going to generalize, kind of see patterns happening. And remember, we if it just has n sides, so this n gone would be n here, and then you'll try and figure out what's going on and come up with formulas. Okay, you'll spend about 10 or 15 minutes on this, and then you'll come back to it after. Okay, but together, let's do the first row and the second row. You have these pictures along the bottom. So triangle, number of sides. That's easy, 3. This part, number of triangles after you draw on the diagonals from one vertex of the polygon. So you go to the triangle, pick one vertex, and notice there are no more diagonals to be drawn because this vertex is already connected to the other two vertices. And this vertex is already connected to the other two vertices, and this one's already connected. Okay, so there are no additional triangles, we just have the one original triangle. And for now, that might not make sense, but that's okay. It will make sense when we get to the second row. Okay, sum of all the interior angles, use the number of triangles. So sum of all the interior angles of a triangle is 180 degrees. Okay. Now these two, notice that these two columns talk about regular polygons. And remember, regular polygons means all the sides are congruent to each other and all of the interior angles are congruent to each other. And we'll also figure out that that would mean all the exterior angles would be congruent to each other as well. Okay, so remember, we have 3 interior angles in here, and if it's regular, that means that all of these angles are congruent. So what do we do with this number 180 to get how many degrees each of these angles are going to be if they're all congruent? Right, so we do 180 divided by the angles. There are 3 angles, and the angles match the number of sides. So that would be 60 degrees. So that means this is 60 degrees in my picture here. Okay, well, an exterior angle, remember we talked about that in chapter 4, that if you extend a side, and I can actually extend all 3 sides and get 3 exterior angles, but I just extended one side. And so we have a linear pair here with this interior angle and this exterior angle. Okay, and if it's regular, that means all 3 of the exterior angles would be the same, so we just need to deal with one. So then what would we do to get this angle, the exterior angle? Right, we should do 180 minus that 60, which would give me 120 degrees. Okay, and since it's regular, that means all 3, there's 3 exterior angles. If I extended these sides, there would be 3 exterior angles. So that's 120 degrees in a regular polygon, that's 120 degrees in a regular polygon, and so is that. Now I want the sum of all the exterior angles. So 120 plus 120 plus 120 is 360 degrees. Okay. All right, now let's do quadrilateral. So quadrilateral, and I drew one there for you. It looks like a square with the side extended. So quadrilateral has 4 sides. Number of triangles after you draw on the diagonals from one vertex. So pick one vertex. So I'll just pick this one. It's already connected there. It's not connected there. So there's one diagonal, and it's already connected there. You only do it from one vertex for this activity. There's more diagonals, but we're only picking one vertex and drawing in all those diagonals possible from that one vertex. So there's only one diagonal there. So that made 2 triangles. So that goes there. The number of triangles after we draw the diagonal in, there's 2. Well, each of these triangles, this is going to be 180 degrees in the sum of these interiors. So that, and that, this angle, this angle, this angle add up to 180. And this angle, and this angle adds up to 180. So together, 180 plus 180 means that the sum of the interior angles of a quadrilateral will be 360 degrees. Okay. All right, so remember, on these 2 columns, we're looking at regular polygons. So, if I erase this stuff, that means all 4 of these angles are congruent to each other. and all four sides are congruent, but we just care about angles right now. So then if I know all four of them have to add up to this 360 degrees, then we do 360 divided by 4, means that if it's regular, all of these angles, the measure of each interior angle is 90 degrees. Okay, so then we know each of these is 90 in a regular polygon, so that each interior angle is 90. Now I want to find the measure of an exterior angle of this regular polygon. So linear pair, 90, 180 minus 90 means this is also 90. So those happen to be the same. Interior and exterior of a regular quadrilateral will be the same. So then you got to remember there's 4 of these right angles. If I extend all of the sides, I'd have 90 times 4, and 90 times 4 comes out to be 360 degrees. That's what the sum of all 4 of those exterior angles would have to be. All right, so now you are going to work on the next 2 rows, and then once you do, or 3 rows, I'm sorry, do the next 3 rows, and then once you do that, then you're going to start writing formulas that kind of generalize what's going on. So in this column, remember we said number of sides is going to be represented by the variable n when it's an n-gon, no matter how many sides it is. So then you're going to see what's happening here with relationship to this n, and you're going to start filling in formulas as you go when you see a pattern. You're going to see a pattern happen here. Okay, so go ahead and pause for about 10 or 15 minutes and work that out, and then you come back and we will continue and see how you did and make sure your formulas are correct. All right, so let's see if you had these same numbers, and then we'll do that last row together to see how you did, and then change it if you need to. Okay, so the stuff in blue is what you should have gotten for these. So if we generalize what's going on here, if the number of sides is 8, notice that the number of triangles is the n minus 2. So if I do 3 minus 2, that's 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. 8 minus 2 is 6. So this one is going to be n minus 2. That's how you get the number of triangles in any polygon. Okay? Now remember, we use the number of triangles here. So once you figure out the number of triangles, what did we do with this number? Well, we had to multiply it by 180 degrees because each triangle has 180 degrees in it. So this is 180 times n minus 2. Because there's 180 degrees in a triangle and the number of triangles is n minus 2. Okay, then once you knew this number, to get the measure of one interior angle of a regular polygon, because they're all the same, you take that 180 times n minus 2 and you divide by the number of sides, because the number of sides is the same as the number of angles. Now I'm going to hold off on this one for just a minute and look at the sum of the exterior angles. What do you notice that is always going to be? 360 degrees no matter what. And how I think about it is when you have your exterior angles, when you extend all your sides, is if you walk around it, it makes a circle, and a circle is 360 degrees. Okay, so the sum of the exterior angles is always 360 degrees. Now this one you could say it's 180 times n minus 2 divided by n minus or subtracted from 180, but that's a lot. We can actually get there faster because you know the sum of the interior angles. And so if I know the sum of the interior angles, I can get the measure of one exterior angle by taking 360 and dividing it by the number of sides. That's going to be way easier because you may not know the sum of the interior angles. You may just know because the sum of all the exterior angles is 360 degrees and you've got 5 sides. Well, you don't want to do all of this other work to get there. You could just do 360 divided by 5 and that would have given you 72 right away. Or 360 divided by 6 sides would give you each angle of 60 degrees. So that's a little better than doing this whole thing. So you just came up and you saw why through this pattern all of these things happen. So in your notes, you may just want to write this out formally because it's a little harder to see it in the table. The sum of the interior angles of a convex polygon, so this is where I said that convex versus concave, these only work for convex polygons. Sum of the interior angles of a convex polygon equals 180 times n minus 2, where n is the number of sides. And in all of these formulas, n represents the number of sides because that's the same as the number of interior angles, which is the same as number of exterior angles. All those numbers are the same. Sum of the exterior angles of, again, a convex polygon, this does not work for concave polygons, is exactly 360 degrees every single time. There is no calculation needed there. And you can pause if I'm going too fast. If you're finding the measure of one interior angle of a regular polygon, that's 180 times n minus 2, all divided by n. And if we ever wanted to find the number of sides of a regular polygon, if we're given an exterior angle, we know that n, the number of sides of a regular polygon, in this case is 360, and you could divide it by an exterior angle measure, because if all of the exterior angles are the same, if you take 360 and divide by that measurement, it'll tell you how many of those angles there are, which matches the number of sides. All right, so let's do some examples of how you're going to use this. Okay, so example 2. The sum of the measures of the interior angles of a polygon is 1800 degrees. So you see sum of the measures of the interior angles. So that tells you that is the 180 times n minus 2 formula. And notice this time they're telling you what that equals. They're telling you that is 1800 degrees. So that we don't know what n is because they want us to find the number of sides, but we do know that the sum of the interior angles comes out to be 1800 degrees. Now we're just going to do algebra and solve. You've got choices. You could distribute and then solve for n, or since there's a number times a parenthesis, you could just divide by that number 180 on both sides. So you get n minus 2, and then that would equal 10. N minus 2 equals 10. Then you're just going to solve. So we're going to add 2. So n equals 2. Now I don't, or 12, I'm sorry. I don't just want you to say n equals 12. Give me the name. So this is where the names are going to come in. So a 12-sided figure is a dodecagon. That would be my final answer I'd like. Okay. So the wording tells you some of the measures of the interior angles, that's your 180 times n minus 2. They didn't tell you n, but they told you what the sum equals, and then you solve. All right, example 3. The measure of an exterior angle of a regular polygon is 30 degrees. Find the number of sides. So if we come back here, if I want to find the number of sides of a regular polygon, I could use n equals 360 divided by the exterior angle measure. So they give me an exterior angle, so I would do 360. So n is going to equal 360 divided by the exterior angle. So n equals 360 times 30 degrees. So you divide that out. And you get 12. So n equals 12. So this happens to be a dodecagon also. It's just coincidence. Won't always be that. So if you read, you've got to read in here the exterior angle they gave me. I want the number of sides. That'll tell you what formula you need to use. Okay. All right, last one. This one, they give you a picture. So first we have to decide how many degrees should this add up to equal right now, because we don't know. I've got 1, 2, 3, 4, 5 angles and 5 sides. So n equals 5 on this one. So I need to do 180 times 5 minus 2 to figure out how many degrees all 5 of these angles should add up to be. So 180 times 3, which is 540 degrees. All right, once we know what all 5 of these angles has to add up to, then I'm just going to add them up. So x plus 90 plus 143 plus 77 plus 103 plus, or has to equal 540 degrees. So since it's a pentagon, we found out pentagons add up to equal 540 degrees. So I'm adding all 5 angles together and setting it equal to 540. Now I'm going to add these up and see what this. So we end up with x plus 413 equals 540 degrees. So now we'll subtract 14. So then x equals 127 degrees. Okay. So again, on these where they give you the picture, you first have to figure out how many degrees all of these should add up to be. And there is one that's in your bookwork that's hard to tell how many sides there are, but if you count the number of angles, remember that's also got to be the same as your n value. Okay? Because there is one where it almost looks like a straight line, but it technically is 2 sides, and they put an angle there. So again, you can count up the number of angles if you're not sure, because the sides are a little, one's almost straight. Okay? So you have a book assignment. So on OneNote, you can pull over, it's in the content library, or I think I tried to distribute to you and it may or may not have worked. But under assignments, there's a chapter 8 assignment guide and you're doing section 8.1. So this is your assignment. It's your pages 510 to 511, 3 through 15 odds, 18 through 21, all of them, not odds on those, 18 through 21 all, and then 24 and 25. The answers should be on Schoology, and then I'll go over any questions that you might still have tomorrow when I get back. Hopefully I'll be back. And then you'll have a quiz tomorrow over section 8.1. Okay. Don't forget to do your highlights and circles right now, and then do your summary that answers the EQ later tonight. So use the rest of the time to work on your assignment and check.